Okay, we are moving into section 2 of the book. It's called Part 2 Case Studies. We'll start with water. So this is on water governance. The key concepts, if I go into the display mode and pull up the pointer, in this chapter we'll be introduced to social dilemmas related to water. So we won't explicitly put it into the dilemma format we had before in terms of the choices, but we'll look at some action arenas and action context as well as the players, so the relative position of the players. We will learn about long-lasting successful water governance systems, learn that many successful systems developed effective institutions without central governmental control, see that water is often governed at multiple levels. Notice that inequality in access to water is a core problem institutions have to cope with. So water availability is often thought of as physical, economic, quantity, quality, and access. In access, you have economic access, physical access, so you have equity problems coming in there, and the cost mattering, and infrastructure. So we won't necessarily put it in the context of what we learned before as to private goods, public goods, club goods, common resources, and so on, but we'll refer to them when it's very clear what we are talking about. But as we said before, there is a context, there is infrastructure within which water governance fits in. So we'll look at each example case study to see what are the lessons that were learned and how they led to solutions, institutions, adaptations, etc. We start with this one, the river dike between Kesteren and Ofjorden in the Netherlands during extreme water levels of the river Nederrin in 1995. I have no idea how to pronounce any of these things. The authors, I think both are Dutch, and they have their experience, at least Marco states his experience here. Although being born and raised below sea level is a common experience for people in the Netherlands, when Eleanor and Winston Ostrom quizzed Marco Jansen, the second author of this book, about water governance in his country, he had to admit he did not know much about it. When governance is working properly, we may not even notice the activities many people are engaged in to bring about success, such as keeping feet dry in the Netherlands and providing water for swimming pools and golf courses in Phoenix. Phoenix, Arizona, which is a desert, actually has swimming pools and golf courses, and often gets yelled at because they often have water issues as well. If there is a failure of some kind, a flood or a drought, we are often confronted with the imperfections in the water government system that led to the failure. In fact, we often see that changes in the operational rules occur after a failure. Such failures are learning opportunities that enable us to improve and adjust the rules. After being confronted with his ignorance, Marco read into the history of Dutch water governance, and the description offered in this chapter is a brief overview of this history. They have a history of many centuries over which living below the sea level has allowed them to respond to events and adapt and create governance structures, multi-level governance structures. We'll get a brief introduction of this as we go forward. It illustrates constantly changing circumstances and how human activities change the biophysical context, which subsequently leads to new action situations. So we talked about action arenas, the biophysical context, and the attributes of the communities that are involved, and this is an example. So again, reading a bunch of text in social science, water governance is the first of many examples that we will present in the remainder of this book on sustaining the commons, or unfortunately not sustaining the commons. Water is really a poster child for the impacts of global warming, population growth, land use, agriculture, irrigation, etc., on how water stress is created physically, economically, and artificially in many cases. So we are finally in a position to give a precise definition of the commons. There are two kinds of commons: commons provided by nature and commons provided by humans. Often these two types of commons interact. As an example, a community irrigation system, water systems, let's say, are given by nature, and humans create a distribution system which leads to irrigation supply and water use for irrigation, and then all the associated issues of water pollution and access regulation, excess use, and so on and so forth, where often we head to tragedy of the commons or not sustaining the commons. The most important distinguishing feature of a commons is that it involves one or several common pool resources over which there are no established private property rights. So a river or a lake is shared, and there are regulations set up to share them, but they are not owned. It's a common pool resource. So non-excludable but subtractable, and so on. The second distinguishing feature of a commons is that it involves actions on the part of the individuals who use it to maintain its productivity. These actions are one of two sorts: making a contribution of real resources, so money, time, or physical capital. These are kind of community farm ponds in many villages in Africa and India, let's say, where also other countries in Asia, South America, and so on, where people manage village resources of water by free labor donation or common pool resources to maintain or make a contribution to the real resource. Or secondly, restricting one's activities with respect to the use of the common pool resource associated with the commons. For example, voluntarily fishing less, which is an example, I think, that's practiced in Lake Victoria before, after the crash happened of the Cichlids and so on. Actions of type 2 are typically associated with renewable resources, and in this case are functionally equivalent to actions of type 1. By not fishing, fishers allow the fishery to regenerate itself, so it's a renewable resource if you manage it. This is the same as investing time and effort into increasing the productivity of the fishery. In general, reducing appropriation, I don't know why I'm fumbling this. In general, reducing appropriation of a renewable resource is equivalent to investing in natural infrastructure such as a marine ecosystem that makes the common pool resource of interest available. This is the same for water management as well, water governance. The subject of this chapter, water, is a combination of both kinds of commons: the natural infrastructure of watersheds, hydrological structures, and climate systems, and the human-made infrastructure of dams, canals, pumps, and treatment plants. Governing the water commons is arguably the most important issue we face today. Okay, this comes up the most often. As we have said before, I don't know why I put that in here again. Have I gone back? Okay, I went back by mistake. As we have talked about before, water resource is one of those important issues we are facing today in terms of adaptation and managing. Actually, it's a renewable resource if we use it properly, but with climate change, you may have reduced rainfall, and there are many examples historically, especially in the climatologically dry regions of, let's say, the west coast of South America, where the Mayas and Incas and so on went extinct, presumably because of water issues, and has also happened here in the Mohenjo-daro Harappa civilization, and many here in the African Sahara region as well. So water governance comes down to handling water scarcity, water abundance, and water distribution, as well as water pollution, right? So we'll look at these things. This is a figure, bit old, but you find many of these. Based on comprehensive assessment of water management in agriculture in 2007, we're looking at water scarcity. So all these green regions have little or no water scarcity. Southern part of China, but northern part of China is very different. Approaching physical water scarcity here in these south central, eastern central US and Mexico, and here parts of Brazil. Physical water scarcity, of course, southwest US and parts of Baja California and northern Mexico are climatologically arid regions. Economic water scarcity, so it's not the physical or physical water scarcity, but it's the economic water scarcity, which means there is distribution issues or sharing issues and so on. And the large parts of Africa here suffer from economic water scarcity as well, and Sahara has largely not unestimated water issues as well. So obviously Middle East and so on are approaching water scarcity here as well. So you can see Australia has physical water scarcity not assessed in the center, but no water scarcity on the edges where rainfall and population together make water available. Is water really a renewable resource, or is it subtractable and excludable? One drop of water can be used multiple times for different uses. So technically, water itself is not subtractable in the sense that the same drop of water used by a city resident to wash their dishes can be used later to water a golf course. So there are a lot of regulations about recycling the grey water and so on. So used waters in residences, I won't go into the details, often called grey waters, which can be used for gardening, irrigation, watering a golf course and so on. This is exactly the same as the situation with the book in our library. One person can read a book now, then someone else can read it later. Theoretically, all the water we have on Earth is getting recycled. So eventually the water that we are extracting from various surface and groundwater sources are recycled over time. So it's a matter of time as well, just like the book. You have to wait till the other person reads it and returns it, or returns it without reading, whatever. The key limit is that the resource cannot be used for two different purposes at the same time. So if clean fresh water is being used for washing, flushing, drinking, etc., that same quality of water is not available for other activities at that time. Even though we can use creative coordination mechanisms and technology to recycle shower water to flush toilets, nevertheless, usable water is frequently discarded as wastewater to the sewer system or the natural environment. At that point, such water needs to be recollected and treated for reuse. Hence, inefficient use of water by individuals leads to a shortage of clean fresh water for the group. Thus, water use is a social dilemma, or as social dilemmas associated with common pool resources are sometimes called, a commons dilemma. Okay, so to that extent we're talking about dilemmas, but we won't go into the options different users have and so on here. Looking at water excess water, so you are looking at flood total economic losses. So risk deciles from 1st to the 4th to 8th to the 10th in colors, going from bluish, yellowish to reddish, and you can see there are many places where flood total economic loss is in the high deciles. So large parts of Europe, large parts of Asia, China, India, Southeast Asia, and so on as well. Total economic loss is found by weighting the value of GDP exposure to floods for each grid cell by a vulnerability coefficient to obtain an estimate of the risk. I won't go into the details, but I've discussed this elsewhere. IPCC defined, based on published literature, a risk as a multiplier of hazard, like flood, times vulnerability, which depends on many socioeconomic and other factors, times exposure, which depends on population density, infrastructure, and so on. There are many details. In the 6th assessment that got recently released, The response is also added to as a multiplier to computing risk, because responses, especially planned early warning systems and responses, can reduce risks, so it's included as well. The vulnerability weights are based on historical economic losses in previous disasters. The economic loss risks are applied to GDP per unit area exposure to obtain economic loss risks. The words are used here and not fully explained in the book necessarily, but the reference is provided that you can look up. The weights are an aggregate index relative to losses within each region and country wealth classification based on the 2000 GDP as the baseline over the 20-year period from 1981 to 2000. Okay, so GDP loss is related empirically to flood impacts and vulnerabilities and exposures. Okay, this is about the global map of irrigation, so it's about water distribution. Percentage of 5-minute grid cell area that was equipped for irrigation around year 5000. 5 minute is the resolution here. 1 degree is 60 minutes. So area under irrigation in percentage of land area, you can see that there are places where massive irrigation happens, the breadbasket of the US, much of India, and so on. There are various percentage areas that I won't go into the detail. The map depicts the area equipped for irrigation in percentage of cell area. For the majority of the country, the base year of the statistics is in the period of 1997 to 2002. This is the global map of irrigation areas percentage. I already read that. 5-minute grid cell area, so it's mapped onto this 5-minute grid cell area, which should be something like, I don't know, 12 kilometers or so. Okay, so it gives you a sense of how water, obviously where irrigation is happening, especially very high here in northwest India into Pakistan, there are agricultural concentrations, wheat and other crops which are grown, and the water is not locally available. It's not from rain, it's transported from rivers or from dams. So dams are built, infrastructure is built to distribute the water for irrigation, and irrigation often is over 70% of the freshwater use in almost all countries. So that's a big discussion, but is a separate discussion in terms of what are the inefficiencies in the way irrigation is done, what are the impacts in terms of waterlogging, pollution, ground salinization, at the coastal regions, because groundwater mining leads to invasion of the seawater, and so on and so forth. Okay, so obviously a lot of the water stresses, water scarcity issues come from over irrigation, because like fertilizer, irrigation is where farmers find it easier to just keep dumping water even if there is good monsoon, for example. This is very common in India. So amount of monsoon rainfall and irrigation water use can get completely decoupled, and often energy use is involved because you are pumping groundwater using energy. So there is that food water energy nexus, which works in really unsustainable and undesirable ways with unintended consequences, but everybody benefits sometimes in terms of cheap food, etc. So we are paying the price in terms of degrading the resource and the water quality and water availability, as well as soil health, etc., biodiversity sometimes, but nonetheless that's the water governance issue when you have water abundance. Okay, so we'll come back and look at water scarcity example from Phoenix and Bali. They provide some really interesting lessons on how community-based adaptations over time have happened, how institutions have evolved in response to water issues over time. Okay.